Welcome to Mastering Solutions. I like to think about the kind of big picture on this problem of what we're going to do before we get into the specifics, because they ask us what is the difference between the first two fringes. And so how do we do that? We need to figure out what the distance, or the y, is for the red and for the blue. So what's the equation for delta y? We know that y is equal to L times the tangent of theta. But if you look through the problem, we're not given any sort of theta here, so we have to find that. So what's the equation for theta? Well, sine theta is equal to m times lambda over d. So what we have to do is we first have to find the theta for the red and the blue, and then plug that in over here to find the y for each of those. Let's make a list of the other information that we're given in the problem. We are told that the diffraction grating has 500 lines per millimeter. If we look here, we don't need D. Oh, we do need D over here, so let's do that. So D is equal to the width over the slits. And in this case, we have 1 millimeter. Now let's put 1 times 10 to the negative 3. So we're in SI units. And then over the slits, we have 500 slits or lines, either way. And then I'm going to leave it like this. I'm not going to calculate the actual value. We're also told that the lambda, we have the lambda for, I'll say lambda 1 and lambda 2. So lambda 1 for red is, let's do blue first for 1. So we have 486 nanometers, 10 to the negative 9, and lambda 2 for the red is 656 nanometers. We're also told that L is 1.5 meters behind the diffraction grating. So now we have everything that we need for the theta for both of them, but we need to isolate theta, so we'll take the inverse sine of both sides of the equation. So theta is equal to the inverse sine of m times lambda over d. And so now we can plug in our information. We have theta is equal to the inverse sine, and they want the first order for the red and blue fringes, so we'll use m of 1, times lambda for blue is 486 nanometers, negative 9, and that's over d, which we said is 1 times 10 to the negative 3 meters over 500 slits. So now we can go to our calculator. And for this one, we want a degree, so make sure that your calculator is in degree mode. You can of course convert it from radians back into degrees if you forget, but by that point you might as well just change it and retype it in your calculator. It's about the same amount of time. So we have the inverse sine of 1 times 486 times 10 to the negative 9, and that's going to be divided by 1 times 10 to the negative 3 divided by 500 slits. So the degrees for the blue is 1406. So 14.06 degrees. And I'm going to leave it unrounded like this just because it'll, save us in case it messes us up later if we don't round. And I'm going to leave that as the unrounded version just so that we get a more precise answer. If we do the red now, it's the exact same thing, only we're just changing the lambda. So inverse sine, m of 1, only now our lambda, as we said, is 656 times 10 to the negative 9 meters. All that is over d, 1 times 10 to the negative 3 meters over 500 lines. Okay, so now we can just go here and copy all this down, and let's change our lambda to, let's see, 656. And the degrees for that is 19.15 degrees. So now we have the degrees for both of our y equations. So we can go back to the blue and we can plug that in to figure out the y for the 486 frequency. So y for the blue is equal to L, which is 1.5 meters, times the tangent of 14.06 degrees. So So we have 1.5 tangent 14.06. And that gives us 0.376 meters. So we have 0.376 meters. This isn't our final answer. We'll show you why here in a second. Let's do the same thing for the red. So we have 1.5 meters times the tangent of 19.15 degrees. Okay, so 19.15. So that is 0.521. So we have 0.521 meters. So now in the question, what is it we need? We need to figure out the distance between the first order red and blue fringes. This, the y, is from the central max out to the first order blue fringe and the central max out to the first order red fringe. We want to find the distance between these two. So we're going to take the difference. So we have 0.521 meters for the red fringe minus 0.376 meters for the blue fringe. Now when we take the difference between those two, we get 0.376. We get 0.145, and that's in meters, so 0.145 meters. And if we convert that to centimeters, we have 14.5 centimeters. That is our distance between the first order red and blue fringes.